had something from a record like that.
And the Chinese used to collect, and still do, collect the water from their rivers and streams, and they would save that water to preserve all kinds of fruits and vegetables. They still do it today. We were right when we said the engine continuous all the time, and also there's that little burst to make it up as well. When you get energy spinning, it usually spins in what we call waves, light waves. And a light wave really is the beginning of all matter. The energy itself spins counterclockwise, and it has it's like a coil where the center is just small, like a spring in a watch, and the center turning is very slow compared with the outer rings of the end of the coil. And light is on, let's say I had a coil here, flat coil, and I stretched it up like a cone, so that the tip of it is just that bit, and it's gravitating to make something. Well, on those lines, it picks up energy. The light is spinning itself, and at various intervals down that light wave, because of the speed it's going, so it compacts itself, gravitates into what we call matter. Now, if I wanted to dig a hole in the garden, I would take the earth away and put it on the side, but I got a heap. The heap came out of the hole. The bigger the heap, the bigger the hole. And when light in the universe spins to create what we call elements, what is happening is that the light spinning is pulling the space content towards itself, compacting it, and it's what you call stretching space. It wants it, so it pulls it all to itself and compacts itself, gravitates. And so matter is really energy stretching space. A light wave would be getting bigger like that. And down through the center, there's a line. You might be saying to yourself, what's this got to do with crystals? It's got everything to do with crystals. So up here, we've got our first, it's spinning very slowly there, and alpha non is the first one there, just to mention one. But as we come down here, we got hydrogen and we got iron and whatnot, because the spin is greater here, like on a bicycle wheel. If you spin a bicycle wheel once more, then the hub is traveling much slower than the rim itself. So where they come on the outside here, they're going much faster, and these are getting bigger. And so you have a wider sweep, so that these are traveling at such a rate, you get your elements form on the light itself, and they're getting heavier. Now, when I say heavier, I mean when we compare one atom of this as compared to another one. We don't say, oh, there's this bulk here. We don't compare bulk, we just go by how it gravitates. Now, the energy we're using is light. And the light compacts itself into these things, and you have what you call an octave. The octave will stretch from here, I beg your pardon, it stretched from halfway here to halfway here. And on one octave, just on music, there's eight elements, which you don't count the 8 elements from one here, you take half. That's half here and 1, 1.5, 2.5, 3.5, 4.5, 5, 5, 6.5, and the other half of this one gives you your 8. You start with half here again. This is how your elements are formed. And they will have different weights because of the position they are on the scale of light. This light here forms matter because it is gravitating. And at the same time it's gravitating, inside that spiral there's one going the other way, which is radiating. But it's behind. Remember I told you it's behind time with the other one. And so the elements that you had formed, they remain there. Now, one little thing that I might mention as just a point of interest is that mass rotates at a certain speed, like the Earth. The Earth rotates at about 19 miles a second. And the speed of light is 186,000 miles a second. Now, the difference between the time of them moving would indicate that there is time, such a thing as time. I will mention this, and I will repeat, it only indicates that there is time. Now, any element itself, or any light wave, must remain in balance. You cannot have more gravitation than radiation. You have to have them both equal. And when you have those elements formed, we find them in the Earth itself. When the Earth was being created, they have cooled down. You got your elements in the Earth. But this is how they were created in the first place. This is how mass was created. Now, when you think of mass, don't ever think of something big. Think of even a speck of sand is mass, or matter, call it what you like. Now, any part of matter that you see, think on continuously that matter is light in another form. If you can accept that, we'll get somewhere. Now, once we have, one of the things I should point out here before we go too much farther is that in creation there has to be rules. God made rules which I guess we call the laws of nature. And one of the things that would indicate this to you is a very simple test you can do for yourself. We have a chart here. This one, a B chart, but have a look at this up here. To indicate the rules of nature. That is like a chart of a pebble dropped in some water. And the pebble drops in here and it starts to send rings out. Now, I don't suppose anybody ever bothered to check it, but if you take a photograph of those rings on the water, leave about 10 rings spread out, and photograph it, you've got something you can work on, like a chart. And if you measure the circumference of this one here and multiply it by the cube root of pi, then this is the circumference of this one. If you take the circumference of this one and multiply it by the cube root of pi, it is the same measurement as this one. So it's increasing, all these rings are increasing one by one by the cube root of pi. And never alter that. That's the laws of nature. Now, a funny thing happened too. That if you take the circumference, or rather the diameter, of the fifth ring, let's see, there's 1, 2, 3, 4, 5. Take the diameter of this fifth ring across here, it will be the circumference of the first one, the same measurement. So if you took the second ring, this sixth ring would have the same diameter as the circumference of the first one. So every 1 to 5, the diameter is the same as the circumference of the previous one, the small one. So you see, even they travel out, they expand. It's not accidental. It never is two different ways. It's always the same. The expansion of those rings on the water are no different to your radio waves. You see the radio waves coming out of the tower, they expand exactly the same. They multiply by the cube root of pi, a law of nature. You never alter that. And you'll find that in so many things, shape plays a part. There's all kinds of things that are natural. We don't have to do anything. Shape plays a part. If everything were in balance, then nothing would move. So we have to have something that creates an imbalance so that nature can use its laws of nature and come back into balance. So if it goes out of balance and comes back into balance, we have movement. Now anything out of balance, there is something wrong. There's something needs correcting. That's why nature puts it back into balance again. But shape is one of the things that will influence movement. For instance, if I had a cup of soapy water and I get a straw and I dip it into the soapy water and I take it out and there's water on the end of it and I just go like that, it drops plop on the floor. If I dip it in again and blow into the water, I get myself a nice big bubble and I can just shake it up and it'll float away. The water, amount and content exactly the same. The only difference was the shape. Now, shape that's quite a broad word, shape. Pick any shape you like and every other shape is in it. There is no shape in this world that is by itself. They all contain each other's shape. For instance, up here, you see this chart, C here? This one here. I got a circle, I got a hexagon, and I got 1, 2, 3, 4, 5, 6 circles and one in the center. Now this is the only perfect way that circles will fit close together and leave no gaps. Now in that circle I can have a hexagon, I can have a triangle, all the shapes are within the shapes. Now I want to point something out here that you probably haven't thought of. You remember I said to you early on that from alpha to omega, that dust to dust, okay. In the light spectrum, colours of the rainbow if you like, we have 6 colours